First experiment, black pepper. Okay. Glass watch. Now we take 10 grams of black pepper. Okay, this is 10 grams of black pepper. Then we're using a grinder to powder the black pepper. After that, we use a hot method for extraction using soak slit apparatus as indirect heat source. So we put black pepper in thimble and soaklet, which connected to chiller for cooling the water in the condenser. After that, we filtrate our mixture by using a filter paper. Now we prepare KOH at 10%. 10% KOH solution. Now using graduated pipette, we add 2 ml of KOH to the filtrate. Then we add the filtrate to a beaker. Then we add some water to the filtrate. Now we see the piperine is flashing out as a white cloud because piperine is insoluble, really insoluble in water. We leave the filtrate in order to precipitate piperine, which is totally insoluble in water. Now we will evaporate the ethanol, all ethanol, and only the aqueous layer will remain by using autoclave. This will ensure that no alcohol will remain to solubilize the piperine. So the piperine, as we know, is insoluble in aqueous layer. So all piperine will precipitate by and obtained by filtration. After evaporation of ethanol, we will leave our aqueous extract 24 hours to ensure the precipitation of piperine crystals. After 24 hours, we will start with filtration. When the filtration is complete, we will see the crystals of piperine. This is the crystal of piperine, as you see. So, also we should remember that we add potassium hydroxide to ensure that all of the piperine is as free base, not as salts. This is one of the purposes of addition of potassium hydroxide. Now we weigh our yield of piperine. This is our yield of piperine. Now we will identify is that compound is piperine. So we will identify this compound using TLC, thin layer chromatography. So we will use pipette. We need a jar and organic solutions. We need ammonia, we need acetone and distilled water. So we will prepare a mobile phase using 90% acetone and 30% of the mobile phase will be ammonia, and only 7% we will use a distilled water in the mobile phase. After addition of these solvent and completing the mobile phase, so we will close the jar and allow the jar to be saturated with vapor. This a thin layer chromatography, aluminum covered with silica gel. Okay, covered with silica gel. Silica gel can easily scrap from the aluminum layer. Now we will heat our TLC paper after cutting the filter paper in this size, and we will heat on a hot plate to remove all moisture on silica gel. The heating of TLC is also known as activation of TLC. Now we will dissolve a few milligrams of piperine in a beaker. So to prepare our sample, we will dissolve the piperine using alcohol. Also we need micro hematocrit tubes or micro pipette, capillary pipette. Using a pencil to apply a baseline on the bottom of our TLC layer. So the baseline should be 1 centimeter above the mobile face. So you should identify the level of mobile face. This is the mobile face. So 1 centimeter above the mobile. So this is the baseline. Now using capillary tube, take a sample. Now we will apply the sample on the TLC. We will apply the sample on the baseline. Okay. We'll place our TLC in the jar. The TLC resemble what? Resemble a stationary face, and the solution resemble the mobile face. So we will add the stationary face. As we see, the mobile face is clamping up on the stationary face, taking a sample with it. Now when the mobile face reach about more than three quarters of stationary face, we will remove the TLC paper. Now we will determine the front line. This is the front line and this is the baseline. Now using UV light, the spot of piperine appear clearly under UV light. Using short UV light. So this is the distance moved by mobile face. This is the distance moved by the sample. So you should calculate the retention factor, RF value. Add a few drops of Myers test. So a white cream precipitate should be formed to indicate the presence of alkaloid. Using Myers test, which will give us a white creamy precipitate which indicates presence of piperine.